Alright, everyone, welcome back. I'm continuing with 5.2. This is page 418. However, before I go into angles in standard position in all quadrants in 5.2, I would like to recall what happened in 5.1. Okay, so an angle in standard position is defined as that angle whose initial arm would be on the positive x-axis, so this one here, and then it goes that way, all right? And your angle is measured counterclockwise. This one is an angle in standard position. Its initial arm is in the positive x, and then its terminal arm will be in quadrant one, and that would be an angle in standard position in quadrant one. Now, what would be an angle which is not in standard position? So take a look at this. All right. So I have this angle wherein it is measured this way. And since it doesn't start on the positive x, it starts on the negative x, it is not an angle in standard position. There is your theta. Are we good? Okay. So let's do some get started parts here. Point A23 is reflected in the y-axis and its image is A prime. So if we're going to be reflecting that over the y-axis, it's probably going to be somewhere like this, okay? It is just a sketch. So this one is A prime. What is what are the coordinates of A prime? So A prime would be what? It is to the left of the origin. So if A is to the right of the origin and 2 units to the right, that means A prime would be 2 units to the left, which tells us it's going to be -2. All right? Well, it's still going to be a 3 for the y. And then it's going to have another image. This time there is an A double prime, and that is to reflect A prime over the x-axis. So maybe somewhere here. All right? So let's call it A double prime. And it will have what? Coordinates. It is still 2 units to the left, but then it's 3 units down, -3. So the next one, it is an A triple prime, and that would be to reflect a double prime in the y-axis. So it's probably somewhere here. So that would be A triple prime, 1, 2, 3. And A triple prime would have what coordinates? 1, 2, 3. It is now on the right or to the right of the origin, which means it's +2, but then it's still 3 below, all right? Are we good at that? Okay. So the terminal arm of an angle in quadrant 1 can be successively reflected in both axes to form 4 different angles in standard position. Now guys, there's a new term here introduced to you, reference angle. A reference angle is defined as that acute angle. Therefore, a reference angle has to be less than 90 degrees that the terminal arm makes with the x-axis. Okay, look at this. This one is an angle in standard position. It has a reference angle of 35 degrees because this measures 35 from the x. Now guys, in the next one, this one, the angle in standard position is 145 degrees, the one that goes this way because it starts with the positive x. However, the reference angle is again 35 degrees because the reference angle is that angle that is measured from the x, okay? It doesn't have to be the positive x. The reference angle only requires you to start measuring from the x-axis, okay? While this one, it also has a reference angle which is 35 because it is measured from the x going this way, okay? While the angle in standard position is 215. While here, the reference angle is again 35 because it measures 35 degrees from the x going down. Although the angle in standard position is going this way, which is 325. Okay. Oops. Okay. Okay. Any questions about that before I continue? Okay. So I'm just looking for something here. I think I'm missing a part. Okay. So um, okay. So hold on 1 second. Okay. So apparently it's gone missing. Okay. So I put it in here. So anyway, I'm doing the um, page 421 where it says trig ratios of angles in standard position. All right, the one in um, shade, the one that is sort of in a shaded part on the top of page 421. It says trig ratios of angles in standard position. All right, and that would be cosine theta is equal to x over r. This is just a recap of what you have learned before. Sine theta is equal to y over r, while tangent theta is equal to y over x. Okay, and r is calculated by getting the square root of x squared plus y squared. Okay, now let us look at check your understanding number 1. Okay, cy, oops, let's check your understanding. Okay, number 1. Okay, I don't know what's wrong here. Okay, never mind. Okay, I'll just do this. Check your understanding number 1. So the point A, B, -2, -4. Okay, so there's a point B, -2, -4. It is on the terminal arm of an angle theta in standard position. Okay, on the terminal arm of an angle theta in standard position. So it says A, determine the primary trig ratios of theta. Okay. Okay, so let's take a look. A, determine the primary trig ratios, meaning the sine, cosine, and tangent. Okay. So once again, I will begin by asking myself, how does this look like? -2, -4. All right, where is it? -2, -4. 1, 2, 3, 4. Just saying. So this one is our point B. Okay. Now, guys, this is how you make use of the reference angle. Now, guys, we are going to find the primary trig ratios of theta. Now, mind you, theta is an angle in standard position. So let's create this line segment here. Now, guys, theta is an angle in standard position which begins here and goes this way. Okay. Now, what is that angle? I don't know. But an easier way to figure out what the trig ratios would be is to make use of the trig ratios of the reference angle. And the trig ratios of the reference angle would be the same as the trig ratio of the angle in standard position, except that the values or the signs, which when I mean the sign is whether it's positive or negative, would depend on what quadrant it is going to be. Now, in quadrant 1, according to the cast rule, I don't know if your math 10 teacher talked about it. I think they did. In quadrant 1, all trig ratios, okay, all trig ratios are positive, sine, cosine, tangent. In quadrant 2, only the sine ratio is positive. Okay? That means the cosine and tangent are negative. In quadrant 3, only the tangent is positive. Sine and cosine are negative. In quadrant 4, all right, tangent. In quadrant 4, only the cosine is positive. Okay? And tangent and sine would be negative. So that is where the idea of the cast rule comes from. CAST. Okay. So how does that help us? What we will do to find the primary trig ratios of theta, which is the angle in standard position going this way, we are not gonna use that angle, and instead we are looking at the reference angle going this way, the reference angle that starts from the x-axis only. And once we got those values, we will just adjust the sign depending on what quadrant it is terminating in. And in this case, it is in quadrant 3. So more on that as we continue with this. Okay. You might be thinking, okay, I don't quite understand this. You will understand it as we go further. So I'm creating a right triangle here, as you can see. There you go. I will call my angle, all right, not theta. I will call it a different name. I will call it alpha, okay? And that alpha is the reference angle, okay? So alpha is the angle going this way, all right? Okay. Therefore, if point B is -2, -4, therefore, the cosine of alpha will be adjacent over hypotenuse. But wait a minute, we don't have the hypotenuse yet. Well, I think it would be better if we get the hypotenuse first. What do you think? Huh? So yeah, let's do that. Let's get the hypotenuse. Okay. So the hypotenuse will be given by this. Um, if this is point O, so the line segment OB, which would be the hypotenuse, will be given by the square root of -2 squared plus -4 squared, which is square root of 4 plus 16, or square root of 20. Or if you want, you can simplify it into 2 root of 5. Okay? So now we have our hypotenuse. Therefore, we can now proceed to get cosine of alpha, which is going to be um, the adjacent side, which is this one. All right? And how long is that in terms of a length? That would be 2, and the hypotenuse is 2 over 2 root 5, and that simplifies to 1 over root 5. Now, mind you, this cosine value is for alpha. That is not for theta. So when we want to get the cosine of theta, we are still going to use the value of 1 over root 5, but we will ask ourselves, okay, our theta terminates in quadrant 3. In quadrant 3, the cosine value is negative. Therefore, the cosine of theta is negative. Let's look for sine of theta, or sine of alpha rather, sine of alpha. Sine of alpha would be this, which is your opposite side, that is measuring 4 over 2 over root 5, which is 2 over root 5. Okay. So if we want to find the sine of theta, we will use the same trig ratio, 2 over root 5, but we are going to ask ourselves, in what quadrant is it? Oh, it's in quadrant 3. In quadrant 3, the sine value is negative. Therefore, the sine of theta is negative. Tangent of alpha. Tangent of alpha is what? So it is y over x, right? It would be the y value is -4, the x value is -2, which is +2. Now, What I want you to do is this. When you get to the tangent, I want you to um, uh, ask yourself, okay, so um, what is it that is going to be the sign? Is it positive or negative for tangent in quadrant 3? All right. So the tangent of theta, we're still going to be using the value 2, but we will ask ourselves, is it positive or negative? And in quadrant 3, tangent is positive. So we're good. Now, this is where it becomes a little bit tricky. So be careful. As you do the angle, as you find the angle, because it asks us to find the angle, tangent theta is equal to 2, you will most likely do this. Tangent inverse of 2. And if you do that, guys, I did it in my calculator. I came up with about 63.4349. Okay, something. Okay. Now, guys, be careful because this one really, oops, sorry. If you notice, 63 degrees is not the theta that we're looking for. Now, if you're thinking, what? That 63 degrees is not the theta. Look, let's go back to the picture. The theta that we're looking for is this one. That is more than 90 degrees. That is more than 180 degrees. So now you're thinking, okay, so what gives? The angle that you actually got is the reference angle that was given by your calculator. Therefore, what you're going to do here is your actual theta, oops, your actual theta, okay, theta is equal to, since it's in quadrant 3, theta is in quadrant 3, therefore, your theta will be equal to 180 plus that reference angle. Okay? And I think it is to the nearest degree, so let's just say it's just 63. So it would be about 243 degrees. Okay? I know that for some of you that may have been a lot of math. So again, I encourage you to stop the video and rewind it if you feel that you need to take some more time to understand that. Okay? So I'll give you some time to think about that and I will continue in a bit.